Okay. So the theorems, you don't have to memorize them, you just have to understand them because we're not doing proofs, we're just applying them in algebra problems. So what the first theorem is saying, if two inscribed or tangent chord angles intercept the same arc, then they are congruent. All right, to sum it up for you, what this theorem is saying, if two angles whose vertices are on the rim of the circle, if they're like, if we're looking at them like Pac-Man mouths, if they're both eating the same arc, they're going to be congruent, which makes perfect sense. Because if you look at the example below, let's say arc AB is 30 degrees. And now we want to find angle X and angle Y. Well, here, isn't angle X an on angle? Its vertex is on the rim of the circle, and it's eating the 30 degrees. What's the formula for an on angle? Arc divided by 2. So that means angle X is 15 degrees. Now, angle Y is also an on angle. And isn't angle Y also eating arc AB? So an on angle is arc divided by 2. We're eating the same arc. It's 30 divided by 2. It's 15. That's what this is saying. It's saying if two on angles are intercepting or eating the same arc, then they are going to be congruent, those two angles. All right, another theorem, just sort of tag off of that, they're still talking about on angles. So they're saying if two inscribed or tangent chord angles intercept congruent arcs, then they are congruent. Again, it makes perfect sense. Right now, these are both on angles. We know an on angle is the arc divided by 2. Do you see how I mark these two arcs congruent? So they're both going to be half of that congruent arc. So they'll still be congruent. All right, let's go to angle inscribed in a semicircle. An angle inscribed in a semicircle. Well, first you need to remember what inscribed means. What inscribed means, an inscribed angle is an angle whose vertex is on the circle, but whose sides are made up of two chords. That's an inscribed angle. Just a general info, that's an inscribed angle. An on angle whose sides are chords. Now they're saying this angle is not just any inscribed angle, it's inscribed in a semicircle. What do I mean when it says inscribed in a semicircle? It means I have an inscribed angle, but it's eating the whole diameter, something like that. Do you see what I just drew? So they're saying an angle inscribed in a semicircle, so an on angle that's eating the diameter, the full diameter, that angle must be a right angle. Why? Well, it makes perfect sense. Doesn't a diameter split a circle in half? Yeah. So we know the top part of the diameter is 180 degrees, and we know the bottom part from the diameter is 180 degrees. Now, if you look at the drawing I have here, isn't this an inscribed angle? C is on the rim of the circle, and isn't this angle eating the whole diameter? Yeah. So it's an on angle, and the angle is half the arc. Well, what's the arc it's eating? Isn't it eating arc BA, which is 180 degrees? Half of 180 degrees is 90. So anytime you see an on angle eating the diameter, an inscribed angle eating the diameter, it will always be 90 degrees. All right, let's look at this example. So in circle O, BC is the diameter, and the radius of the circle is 20.5 millimeters. Chord AC has a length of 40 millimeters. Find AB. All right, so we know AC is 40. Then it says the radius is 20.5. Where do you think I'm going to label that 20.5?
At the center point of the circle.
From O to what?
O to B.
B. O to B is a radius, that's 20.5. Is there any other radii you see here, Oscar?
O to C.
O to C. So what does that mean for B to C?
B to C is
Yeah, 41. Right. Now, we want to find AB. There's one more thing before we find AB that we have to know. Do you see angle BAC? Angle BAC, angle A? Isn't that an inscribed angle? And what is that inscribed angle eating or intercepting? The diameter. What does that mean for that angle A?
Right angle.
It's going to be a right angle. This is now a triple, something 40, 41. 9. All right, I already told you this. Tangent, tangent angle, and its arc. So if you have a tangent, tangent angle and its arc, they add up to 180. So if the angle's 50, the arc has to be 130. I just did that exact problem. All right, let's go to sample problem number 1. Given A, B, and C are points of contact. Arc AB is 145. I don't know why my computer keeps doing this, but this should be an angle symbol. Does yours say angle?
Yeah.
Okay, good. And then it says find angle Z. That should also be an angle. Just make sure yours says angle. All right, so arc AB is 145, so I'm going to go ahead and label this. This is 145. And angle Y is 48, so I'm going to go to angle Y and I'm going to label that 48. Now we want to find angle Z. Do we all see Z, X, Y, the shape?
Yeah.
What is it?
It's a triangle.
It's a triangle. What do we know all the angles in a triangle have to add up to be? The sum, the interior sum. 180. I already have angle Y. If I somehow find angle X, wouldn't I then be able to find angle Z?
Yeah.
All right, so let's look at angle X. Look at angle X. Isn't it a tangent-tangent angle with the circle? So what do we know about a tangent-tangent angle and its arc? Tangent-tangent angle and its arc have to add up to 180. We learned it yesterday. We just repeated it again today. So for me to find angle X, I'm going to say angle X is equal to 180 minus 145, and we will get 35 degrees. So now I know, oops, don't want to do that. Now I know angle Y is 48. I just found that angle X is 35. Can I now find angle Z? Yes, I'm going to add up the two angles and subtract from 180. So angle Z will equal 180 minus the sum of 35 plus 48. And if we add these, we are going to get 83. Does that sound right to you?
Yeah.
Yep. So angle Z is 97 degrees. Can I go? All right, so this is a great problem. Let's put a star on this. I'm going to put a point here in the middle. Let's call this point T so I can reference it. And let's call this left circle O and the right circle M. And there should be more information up top where it says PY and QW are tangents to circle O. Okay, arc WZ is 126, so I'm going to label that. Arc WZ is 126 degrees. Oops, oops, I labeled it correct. Arc XY, which is right here, is 40 degrees. Find the measure of arc PQ. So let me highlight. I need to find this arc. Has everybody labeled? Okay, so I need to find arc PQ. Everybody look at angle QTP. I'm going to call it angle 1. Everyone look at angle QTP. I'm going to call it angle 1. Do we agree angle QTP is a tangent angle to the circle? So what's the relationship with the arc and the tangent angle? They have to add up to 180. Right? Any information on circle O at all or anything on this side? No, all the information was given on this side. So we obviously have to start with circle M and that whole side over there. But the saving grace is there is a connecting factor here between circle O and circle M. It's my vertical angles, right? Isn't angle 1 and angle 2 here congruent? So this is angle 2. Is angle 2 a tangent angle to circle M? It is?
Yeah.
Oh wait, no.
No,
It's a
angle 2
secant.
is not a tangent angle. Why? It goes through the circle. So good, Mia. It is a secant angle. Right. But it is an outside angle, right? So can we use a formula to find the measure of angle 2?
Yes.
Yes. So that's what we're going to do first. We're going to use the formula to find the measure of angle 2. So angle equals big arc minus small arc divided by 2. All right, so if you want, if it helps you, you can highlight or trace the angle. All right, its big arc is 126. Its small arc is 40. We subtract those, then divide that difference by 2. So where are we at? We're going to be angle 2 equals 42? 43? Yep, you're right, 43. All right, so angle 2 equals 43, which means what? If angle 2 equals 43, then angle 1 also equals 43. Now, since we know angle 1 equals 43, can I find arc QP? Yeah, arc QP will equal 180 minus 43, which is 137 degrees.
Did you know it wasn't like the tangent like circle M?
Oh, because a tangent angle can never go through the circle.
It only
So,
touches the circle once.
so like a tangent angle could only touch a circle once. So like if I extend this, is it ever going to touch the circle again? No. So a secant angle goes through a circle. Okay, let me see if there's anything else worth doing. That's a proof. Nope. We are good here.
Yay.
All right, so we are done with section 10.6. Now we're going on to 10.7.